next talk is going to be by Arti Parikh, right there. And fun fact about her is that she's pretty awesome. She's the organizer of Women Who Go Silicon Valley and the Go Meetup in Silicon Valley. And if you're around Silicon Valley and you're a woman or part of a gender minority and would like to participate on a free Go tooling workshop taught by me here, by myself, on October 20th, make sure you talk to her or you find Women Who Go Silicon Valley and you'll find all of the information there. And today she's going to be talking about the evolution of serialization formats and usage in Go. And I told her I'm expecting to see lots of XML. So we'll see. Round of applause.
Okay. Hi, everyone. Can you hear me? Yeah, okay. My talk is evolution of serialization formats and usage in Go. So I've been in programming for a while, and I lived through the growth of Java. I've programmed in Ruby, I've shipped production code in Fortran, Ruby, Java, and now I'm writing in Go. So this is going to be a little bit of walk down history. This was my abstract. It was mostly because a lot of noise around gRPC and protobufs, and there were a lot of questions coming like, why do we need a new thing? Was Thrift not good enough, or how is it different? How's protobufs different from JSON and all of that? So I had all these questions in my head, and I just wanted to learn it for myself and then share it with the community. So this is my kind of talk is mostly focused on that. So why do we need to serialize? If you ask that question, like what is really happening? We want to store stuff in the database. If you've used MongoDB or whatever, you've heard of BSON and other formats. If we need to send data through the wire, so a lot of these protocols and stuff that are sent to the wire are also serializing data before they send it. We need to maintain data integrity. We need to keep schema versioning so we know that, hashing is kind of a way to, say, if you have two serialized objects, how do you compare the two? So maintaining data integrity. And the other thing is we need to execute remote calls. So we send a bunch of data to the other server on the other side, and it needs to execute some function. If anybody remembers COM, DCOM, and all those technologies, so distributed data objects in component-based systems was like, the thing back then. And it still is, right? We distribute objects, we cache objects, and how do we serialize those things and send it around? So a little bit of history. So the origins of all the serialization, I felt like was in networking and cryptography and coding theory and all that. They were all binary protocols first, C-based, things. If you go and dig up like old RFCs, and there's this IETF standard for XDR that was written in mid-1980s that was invented at Sun. There's XNS, at Xerox Network Systems, had that. And that was the protocol for LAN in 1977. And we've all used like X.509 certs and all of that. That's also a series of protocols that were from the 1980s. So there's a lot of history. I'll go a little bit into XDR. Because this was interesting to me because it's like the foundation for file systems. NFS, ZFS, they both use XDR. And Open Network RPC was, using, XDR. But what was interesting to me was that what I was researching was that, the Stellar Crypto project just picked it up and said, this is a really simple, protocol to implement, and we'd rather use this than use like protobufs and other stuff. And that, to me, was interesting. And when I started digging into why, they were like, because it's simple to implement the parser in it versus like the newer protocols. So technology that's like from mid-1980s is still sometimes simpler, just like Makefiles are still simpler than, Webpack and all of this other stuff. So the thing in XDR was, so I put this here, it's called length value encoding. So something to something, and I'll go into it in the next slides. There's also this thing like type length value encoding that's used in protobufs and others, and that also comes from networking. So, so just wanted to share that. And the implementation of XDR, I've put a link on that if you want to check it out later. How are things today, right? In 2018, we've got, if you look inside the Go source encoding, there's like all of these different like packages that are provided. And these are not comprehensive, right? If you go to Go, I look at all of these and I think these are these are some of them, but if you go to Go source archive, which has like the tar and the zip, I still count them as serialization. If you go into Go source, I think it's UTF, the UTF-18 and all that, that's also serialization in some way. It's encoding, like you're putting it in a standard. Even images, right? I always think like when you're encoding, decoding, you're saving data for the futures, so you can read it back in that format. But in 2018, we have JSON, XML, we have the GOB in Go, which is a binary format. Protobufs, Avro, flat buffers, Captain Proto, these are some of the ones I wrote. And in the 1990s, if anybody remembers Cobra, or Corba, I said Cobra, but Corba. So if you've done all of this, there's always been this back and forth between, whether to use a text-based format or a binary format in the systems. So, so what is so I'm going over a little bit about selection considerations. So when you're writing a system, how do you pick, what protocol is suited for your needs? So these are some of the questions, right, that come to mind. Do you just roll your own? So I worked at a startup that we wrote our own custom binary protocol. We were sending data from the firmware all the way through the iOS app to the cloud and storing it. So at every step, there was some crypto also attached. There was some message signing and all of that. And the team was ex-Apple, and they chose to write a custom binary protocol. And I think, looking back, protobufs would have been perfect for that project, but they chose that, right? So how do you determine what to use? Some of the things to think about when you're picking a protocol is, what kind of tooling is available. So doing that custom binary protocol was hard. We didn't have any tooling. Every time we had to do something, we had to, write the parser in Go. When we rewrote the services from C to Go, we had to, do all of the work again. Versus if you had used something that had tooling available, it's easier. And what languages are supported by your protocol? Is it a specification? How many people have implemented that specification in the various languages? Are some of the things that, these are some things that come to mind. So another thing is that if you look at these protocols, some of them are reflection-based. Anytime you're encoding, especially deserializing, you will be using reflection, and you'll be like mapping it back to some types and saying, okay, this thing that I decoded has to map back to this type, and I need to go back and construct my object, right? So it's a lot of overhead. So how do you reduce that? The one technique is to use code generation. So that's why some of the serialization protocols have the interface definition language, like an intermediary format that just gives you what your protocol looks like, and then you can write generators for all these different languages, right? So that could be the implementation. You want to know whether the type of what you're encoding is carried with the data, or it's not, because that's important. If the type is not carried, how do you reconstruct? Where is the work being done to reconstruct, the object back in the system? So those are some of the things. Some of the other things about efficiency and speed are does it do zero copy serialization? That's a concept where do we have to, when we read this data, do we have to put it in temporary buffers before we finally get to use it, or can we use the underlying buffer to decode this. So and it's also different for each of the specifications. If you dig down deep in the specifications, it's easy to do like your regular data types, like I wouldn't say easy, but it's like the fixed data types like ints and bools and strings and all of that. But how do you do variable length data, right? Your pointers and your arrays and your lists. How do you do those? And is versioning supported in the protocol? So going a little bit into Go encoding. So the Go encoding package is really nice design. If you go into it, it's like there's a text. There's two functions for text, and there's 2 functions for binary, and everything just works from that. So if you're using the higher level, if you're using JSON or XML or anything, at the end, you can override these and provide the implementation. If you create your own, text implementation for something, you can override this. And I'm using the word override from I've written a lot of Java. So and you can, implement this in that way. So I'm covering the text-based formats now. So the JSON. The JSON package is pretty interesting. You've got Marshall and unmarshal that functions for JSON values, and then you've got encoder and decoder functions for streams. But what I find really interesting is that it allows you to, it also has this marshaller interface that allows you to implement your own Marshall JSON for custom types. This is what I was talking about with flexibility. So you can, when the serializer is called, or Marshall is called, or JSON.Marshall is called, it recursively encodes the whole tree and then calls the Marshall JSON if it's available. And if it's not available, it drops down to encoding.textmarshaller. So if you look at if you spend some time looking at the code is pretty complex. It does a bunch of caching too. But at the end of the day, this is the recursive call is what it's doing over and over in your tree. And it's pretty interesting. So the standard library has this the JSON serializer uses lots and lots of reflection. It's slow. So there are people in the community who've written FFJSON and EasyJSON, which are alternatives that use code generation instead of reflection, and they're faster. And so you have those options in the community. If you come across like, oh no, our calls are too slow, you can use something else. And Swagger, for example, which if you're writing REST APIs, it uses EasyJSON. So that's something that you might want to consider. And XML is pretty much the Go encoding XML is pretty much based on the same sort of pattern, and it implements XML 1.0 parser. I am not going to go into that, even though he said you're going to go into lots and lots of XML. I'm not touching that. I think JSON is where most people are using REST these days, and this works really well. There's a huge number of blog posts on this, and I'm going to have references at the end of my slide. And a really good one is by Ben Johnson on Medium, and I highly recommend you read that. There's one more by Dave Cheney on Gopher Academy. No, not Dave Cheney, John Calhoun on Gopher Academy. That's really great. That goes through all the different patterns that you can use. So the transport mechanism for these, right? So for REST, it's JSON over HTTP. SOAP is XML. XML RPC is pretty much HTTP. Those are some of the transport. But JSON RPC is implemented in the standard library, and it's a specification. And so even though if you go and look at this proposal, I found it really fascinating that net/RPC has been frozen. And if you go and look at the comments, Rob Pike has a comment. It's like, yeah, we need to direct everybody to use gRPC. We need to stop using net/RPC. I don't think he said we need to stop, but he said we need to direct everybody to use gRPC, so it's frozen. But the JSON RPC pack is still alive, and you can use that if you have an implementation or if you're porting something from a different application. So Now I'm going to cover the GOB. The GOB is interesting. I used it, I've actually used this in production for encoding, decoding images where we needed to save the JPEGs and PNGs. It is binary. It's a binary format. It's faster than protobufs because it does a lot of optimization. I believe that Rob Pike himself wrote this package. That's what it looked like. I think the blog post, gobs of data, is really awesome if you want to understand like low-level, stuff that he was thinking about. If you want to understand the thinking of, the design of this, it's a really good one to read. I learned a lot from it. This one line was GOB streams are self-describing. This again goes back to the concept of the schema is embedded in the protocol, but it does something really different where it defines an ID for the type, and only the first time it sends the schema, and then the other times it just sends the ID. So the stream looks. So if you read that blog post, it describes it beautifully on that, and I think it was doing a lot of optimization. It was also using the unsafe package underneath to do the optimization up until Go 1.4. And then I think they moved to reflection. So it's slightly slower than before, but they say it's still pretty fast, it's simpler than protobufs. But this will only work if your whole stack is Go. If you're working in a polyglot system where you've got Go and Java services and all of that, this is not going to work. Like if your whole company is whole hog, just using Go, this is great because you can get like more benefit than protobufs. So now protobufs. Well, with protobufs, I mean there could be like multiple, like there could be a whole conference on protobufs. So I won't go into all of the details. I'll talk about some basics that I've used protobufs with gRPC myself. And it's language agnostic. It's nice. You've got it reminded me of Corba that I had used back in the 90s. So you've got your interface definition language. You've got, types and, all of that. And then you specify, and then you generate you have a compiler that generates the code in various languages for serializing, deserializing. Now you're using that code to make the calls to the other system. And it's really great for microservices. It gets, it has, schema evolution. You can add fields at the end, like if you're, changing your schema or you're sending more data. But you always need an ID when you're evolving your schema. That is one of the limitations, or you could say features, or of protobufs. So gRPC is, just covering it here for, the sake of this is where things are going, right, for microservices. So it's a universal RPC framework. It's getting very, very popular now because of, I think, HTTP2 also. People want to have more, use HTTP2 for transport. It's faster. And it's having a lot of adoption in the microservices world in companies that have old stacks, or they have a lot of Java code, they have other code in other languages, and now they can bring up a whole new text language stack without without causing any problems, right? You can have another whole language stack in your company. Companies like Netflix and PayPal, we have multiple language stacks that we have to support. So the thing with gRPC is it does not specify which serialization you need. But it's there's so much good documentation with protobufs that it's kind of become synonymous. But flat buffers are also used with gRPC, so that's also an option, and I'll talk about flat buffers in a second. So to me, as someone who's been around for a while, I think that it reminds me of, protobuf and gRPC reminds me of XDR and RPC from 20 years ago. It's sort of the same thing, but we're doing slightly different things. So not that much change. While doing this research, I thought Avro was my the most, I don't know, my favorite protocol, I would say. I really liked how it was so easy to read, and the schema was embedded in each of them, written in JSON. It was readable, but it's still binary. So Avro is used in data processing systems. Hadoop and Kafka systems are using that. It has a specification, which is good. And then it has a popular Go implementation from LinkedIn. And there's some benchmarks attached to the speed of it and why people are using it. And it's still you can implement it in any language because it's a specification. And so that's really good about that. One thing I wondered is why not many of the new serialization protocols are actually making it to IETF standards. Like, people don't submit RFCs for that anymore. They're pretty much lie around as specifications now. So I just wondered about that. Like, I don't know, maybe someone at Google or LinkedIn will someday say, oh, I want to submit it, and it'll become a standard. But it's not a standard. So next is flat buffers. These were designed for gaming. This also came out of Google. So efficiency is really, really important. These are like highly optimized, hierarchical. They take the hierarchical data and make it like flat binary buffers. So if you read their docs, I didn't play with this. I read their docs, and I was like, wow, there's a lot going on here. So they just flatten out the buffer, and then during encoding and decoding, you're just directly, during decoding, you're directly reading that buffer, and you're not creating the intermediate buffers to use it. It has a lot of language support as well. The good thing I found was that it seems like they've set themselves up for success because they are supporting protobuf IDLs directly. So if you need to move to from protobuf to flat buffers and you're using gRPC, you can use the IDL. I don't know if any companies are doing that, but it seems like it's doable to simply start using it in your gRPC applications. So it also supports schema evolution, doesn't need the ID. The next one I'll talk about is Captain Proto. So I had a discussion with this author on Twitter. When I read, it was so beautifully written. When I read, his reasoning behind, what I read was he was one of the original authors of protobuf, and then he went and wrote Captain Proto. So I think he works at Cloudflare now. But it's a binary format. It has a specification. So what he said in his design is it's designed for the modern CPU. Is because he arranging the data with proper alignment, making sure that the little endian byte order is used. So it can the CPU so it's really fast. So CPUs can read that much fast. There's no conversion involved, but it doesn't have much adoption. So that was the question I asked him. I was like, why is it not being used that much? Like, it seems like it's so much better than protobufs, but I guess it needs a community and maybe a company to get something adopted. So this is a really interesting protocol to sort of play around with. And then this is, I think, the last one I'll talk about is simple binary encoding. So this is extremely fast, used in financial applications, and I think it's worthwhile to read the design principles of why they wrote it, right? So they clearly these were they picked 6 principles. It's again going back to it's almost like how the compiler works. They're going back, so the serializers are using some of the same principles that the compiler is using for alignment, for mapping and all of that to make it very, very efficient. So depending on your application, you may need it or you may not need it, right? Depends on what you're writing. So that's that. And there's a whole set of serialization benchmarks that have been written on the protocols that are out there. I have links to the data on that. I'll share the slides later. And I think, yeah, so I have one more slide. Is more like question to the audience, like, how do you pick one, right? Depends on your goals. I mean, if you're writing something if you're writing web apps, JSON, XML, not XML, don't use XML. JSON plus gzip is fine, and it's sufficient. Like, why even go to gRPC? Like, unless you're doing service to service stuff, or, that's always like, why add more like cognitive overload if the system is like working? If you need scale, if you need like really low latency, then it makes sense. That's if you're working in gaming, it makes sense to use flat buffers, right? If you're working in financial applications, it makes sense to use SPEs. So yeah, that's all I had. So thank you very much, and thanks for listening.
Great. Thank you.